see what happens right here. Look at this, Cameron. Is that my computer?
That is your computer right there.
And this is the first stage right here.
That is correct.
Boy, it makes pretty quick work of everything, doesn't it?
Yes, it does.
And basically what you're doing, can I touch this? Is it all right?
Yes.
Look at this.
That's a circuitry.
Yeah. You're just chewing it all up.
All of it.
And it goes from here up here.
To a granulator, which it has a screen that will reduce the material to a smaller size.
So this is just the first stop. It's got to go up there and be reduced even more.
That is correct.
Now it's getting really interesting. You brought us into the next stage of things because we saw it when it was kind of chopped up. Now we're seeing it when it's really chopped up.
Correct. From here, we take the material from that size, which is about 3 to 6 inches in length or diameter, and we bring it down to a size where we can separate it, which is about 1/8 to 1/4 of an inch.
Now when you say separate, what are you talking about?
We use centrifugal forces to separate gravity, motion, air to separate the material. As we know, aluminum is lighter than copper, copper is lighter than lead.
So what have you got? One of these? What is this right here?
This is right here a larger size copper with brass and zinc.
Whoa, look at this. This is brass and zinc.
Brass, zinc, copper.
Wow. Look at that. And then this is...
It's the same item, just smaller size.
Can I put my hand up there?
Yeah.
Whoa. Now all of this is coming right out of the old
computer.
And
correct.
the old television sets.
That is correct. Yes.
Now where's the aluminum? Does that come out another bin? And
we have to concentrate the aluminum enough so that we can separate it at the end. And that will go to another process.
So it goes down one more process.
Yes.
And what happens to the plastic and to the wood?
The plastic will be on that side. We also separate that. We can give you a picture of that.
All right, so we got plastic, we got wood, copper, aluminum,
and zinc die-cast.
And zinc.
Correct.
Wow, is there anything left?
No, that's pretty much it.
What I mean is, when you get through grinding those computer screens up, there's nothing left.
Nothing left.
Wow, let's get one more look at this, because this is fascinating. Look at this. There are not many places that you could stand in front of a mountain of plastic, but we can do it here. Introduce yourself to everybody, Tony.
Tony Lupica of Electronics Partners Corporation.
And your position here is?
I'm a marketer, and I'm also a technologist.
A technologist. There's a lot of technology going on.
There's a lot of technology here.
Now, we watched the aluminum and the brass and the metal coming out over there. Where did the plastic come from?
The plastic comes from the cases of the monitors and from the backs of the televisions.
But I mean, had that already been taken out before the metal was being taken out?
We have a process where we can separate it electrostatically or by weight, and it will be taken out before the metal goes further down the machine.
Who came up with all of this?
Oh, Jim Mejia designed all of this stuff.
Because, I mean, this is like groundbreaking technology.
It is. It's pretty much proprietary and unique.
And what happens to all of this plastic? You literally have mountains of it here.
We do, and we generate more than you see, and we have homes for all of it. This plastic here can be used in concrete to fill concrete. That's usually what it's used for. We also have it sometimes turned into vases, so it's reused as plastic as plastic utility.
You're kidding?
Yeah, it's beautiful stuff.
Who decided that this can go into concrete?
The concrete manufacturers that we spoke to. We work with them.
Before this, where was it going?
I presume into the landfill. It sure wasn't coming here.
So it did not have any good purpose.
No, unfortunately, this plastic can be quite difficult to reuse because of the type of plastic it is. And really, you can't heat it up and reuse it like you normally would think you could use plastic. This stuff basically stays in the shape that it's in permanently, and you need to find something to put it into, to sequester it.
And isn't that interesting? Because a large part of these computer monitors and all of that are made up of plastic.
They sure are, and they're getting more and more all the time because plastic is cheaper and more moldable than the metal is.
All right, we got plastic here, and we've got, now this, to the untrained eye, would look like sand.
Looks like sand, yes.
But it's not sand,
nope,
is it?
That's glass, ground right down to powder.
Right off of the monitor's screen?
Yes, the glass CRTs are reduced to the sand that you see here.
Now, this is an amazing process, too.
Yes.
What is this used for?
This sand here can be used also in concrete. It is, after all, essentially sand, even though it's glass, and the concrete will hold any lead that might be in the glass, and it will stay in the concrete so it doesn't make it into the environment.
Wow.
Yeah.
This is an amazing thing, I think, for most of us to realize that these kinds of uses can come out of monitors, the screens of
yes.
monitors that would have been put into landfills.
Normally it would be going into the landfill. We found a much better use for this stuff.
Now, James, this is totally different than the plastic and the glass that Tony just showed us.
Right.
This is what?
This is actually the copper fraction of the universal waste products that we process. And this is the copper. It's a combination copper tin, and it's sold to the local copper smelters, and the brass products are made from these types of materials.
Okay, so this is copper and tin. This is...
It's the same chemistry, however, just a little bit larger.
They're a little thicker.
Yeah, a little larger and denser, so sometimes the customers require higher density items depending on the types of operations that they're using.
This is even more dense.
Correct.
Up here, and this is...
the aluminum fraction of televisions. A lot of the televisions have aluminum for heat release mechanisms. Basically, it's like a radiator inside to keep things cold.
Now, what happens to all of this aluminum?
The aluminum actually is taken to a California aluminum smelter, and it's converted into an ingot, and from there the ingot is converted into other items.
Smells like aluminum.
It does have a distinct taste and smell
now,
to it.
I'm not
yes.
going to taste it.
Yeah.
I'll just smell it.
Well, believe me,
you're not going to talk me into tasting this
I've
stuff.
smelled I've tasted a lot of things with my nose.
And what is this right here?
The same thing. This is more of the higher precious metal fraction of the unit of the universal waste.
Wow, this is just fascinating. And all of these boxes.
And this is a high tin copper
are just
product.
full of these teeny little. Everything is, look at this down here.
Yeah, this is from actually the insulated wire from power cables that are associated with the larger electronic devices.
This is heavy.
Yes, it's a #1 grade copper, and it can be sold as a cathode grade copper back to the smelters.
Boy, now this is valuable
it
too,
certainly
isn't
is. The copper, the commodity markets are double of what they were 2 years ago.
So this handful of copper right here, I could just put it right in my pocket.
You probably have about $1.40 in your pocket, yes.
Now this looks like it's barely been through the grinder at all.
This went through the initial process, which is the size reduction, and it was pulled out through, with a magnet.
Now why did it not make it to the final grinding process? What would you do with something like this? You got a lot of it.
Correct. Mainly this is composed of just steel. I'd say it's about 99% iron, which is ferrous.
Yeah, but you got a little bit of wire here.
That right there it's deceiving. It's actually steel. It's coated. It's copper coated steel.
Boy, you learn to have a good eye on this stuff, don't you?
You have to.
And I guarantee you, there's no little bit of copper that snuck its way in here.
If there's any, I want it back.
Yeah, every bit of the copper is in the copper box.
Correct. That is correct.
And because you're basically talking about commodities that have a price change every day, up and down.
Every day, every second of the trading house, yes, it changes.
And now it's time to get back to our original company that picks all this stuff up. And there's another aspect of all of this that I'd never thought of before.
Absolutely, Huell. Many people don't realize the amount of strip mining that happens in the world today to get all these materials raw out of the earth. And what we're providing is the next version of strip mining. This is a strip mining facility.
Without damaging the earth.
Absolutely, absolutely.
So what kind of strip mining would be cut down on because of all of this?
Oh, copper, gold, silver, all the precious metals and other types of metals that are taken from the earth.